Good morning, guys. I'm going to make this short because I've already recorded it once and it recorded completely without audio. So I will not go through every single question. I would really encourage you and your group to work them all that are on your notes page. But if you don't, you don't. And you just don't get that extra practice. I can't control that. So without further ado, let's skip down to looking at this graph. If you think back to unit, let's see, this is 9, so it's unit 7. Unit 7 was on quadratic functions. And if you remember, a quadratic function is easily identified because it has a highest degree of 2. So in standard form, you can easily see that degree of 2. In a graph, a quadratic function makes a U shape, which we call a parabola. If nobody said that, shame on you. All right, from there, we can look at our graph, and we should be able to easily identify each of these key features. Remember, the y-intercept is the point where the graph crosses the y-axis. So we have 0, -3. And x-intercepts are the points or point where the graph crosses the x-axis. Remember, I said points because you could have more than one, like this case in which we have 2, 1, 0, and 3, 0. Next, you should be able to look at your vertex, and our vertex is at 2, 1. Then the maximum and the minimum. Now, our maximum, because this graph has a maximum, is our vertex. We classify that vertex as either a max or a min, and we know that this is a max because it is the highest point on the graph. Typically in class, I'd ask you to draw me a parabola in which it's the lowest on your whiteboards, and hopefully everyone drew a parabola where it opens up and we have a lowest point or a minimum. Here our graph opens down. Now, axis of symmetry is that point where the graph can be divided in half. In this case, if we look at our parabola, a vertical line going straight through that vertex would be our axis of symmetry. And our axis of symmetry here is represented by the equation x equals 2, or the x value of the vertex. This is the axis of symmetry. From there, we can go ahead and take a look at our vocabulary. Nothing too new here. That first one, solutions, we've already started practicing using those. Remember, solutions refer to the x-intercepts, which include words like zeros or roots. We would use all of those interchangeably. Think back to when I talked about how I called the charging block or box a nugget. We use all of those words interchangeably. They're synonyms. All right, nature of solutions is how many potential x-intercepts your graph might have, which I'll go ahead and we'll talk about that on the next slide. But no, there's 3 options. You can have 1 solution, 2 solutions, or no real solutions. Last thing is, in order to solve by graphing, you should be in standard form, which means they are from highest to lowest exponent or descending order. And all of the terms are on the same side of the equation. So if you start off with something where it looks kind of like this, remember, you got to move C back over. Use your inverse operations to get them all on the same side of the equation and equal to 0, which we would want it equal to 0 because we are looking for x-intercepts. And when you have an x-intercept, the y value is 0. So, natures of solutions. I mentioned that it could be 1, 2, or no. And this gives us an example of each. This purple graph on the left, you should notice that it clearly has 2 x-intercepts. So this would be 2 solutions. And I've picked easily identifiable x-intercepts for these graphs. You will not always have that. Sometimes your x-intercepts will be decimals. They could be irrational numbers. But here we can easily identify these as -1 and 5. We always write x-intercepts as ordered pairs. Our second graph is clearly a no real solution. And we use that word real there because once you get to algebra 2, you start talking about imaginary numbers in which this equation would have a solution. It's just not a real solution. It's not a point that can be seen on a graph. But notice, nowhere does that orange graph touch my x-axis. Lastly, we would look at this blue one and notice it has one x-intercept, so this would be one solution. And it's at that point 5, 0. From there, let's look at some detailed examples. Now, I've already pulled up graphs for these or kind of have graphs sketched for these. I'd absolutely love for you to type each of these equations into your Desmos calculator or your yellow calculator just to get the practice of looking for those x-intercepts. An important thing when you do that is to go and find the x-intercepts. Don't just assume their value. Now, if you pull these up, you will see that we get these exact solutions. But if you look at this first one, if we graph it, we've got 2 solutions. And so the nature is 2 solutions. And the solutions are 1, 0 and 2, 0. Our next graph, you should notice, also has 2 solutions. But if you look closely, this is going to keep going down to create our parabola. We know it forms a parabola because it has a degree of 2. And on this graph that I've already created, you can't zoom out. But if you're using your yellow calculator or Desmos, you should definitely zoom out to see the rest of that shape. But we should have 2 solutions, which are 6, 0 and negative 8, 0. Lastly, if we take a look at this one, again, another parabola. Notice as opposed to the first 2, this parabola opens down, meaning it has a negative a value. It's still 2 solutions, which are negative 6, 0 and negative 1, 0. Remember, ordered pairs should always be written in parentheses. Now, if I asked you to sketch me any graph that would work here, 2 real solutions, meaning it has 2 points. So you can pick any 2 points, except I want to make sure you have an axis of symmetry at negative 2. So if our axis of symmetry is right here at negative 2, remember, that's the middle. So the x-intercepts you pick should be equidistant from that axis of symmetry. So let's start off here. If these 2 are my x-intercepts, they are equidistant. Notice they are both 1 away from the axis. My parabola could look something like this. I want it to be symmetrical. I could choose this point. So notice I am 3 away from negative 2. So I'd also have to go 3 away from negative 2 over here. And let's make it have the same vertex. That's fine. Again, as long as it has that axis of symmetry or that vertex at negative 2 and 2 x-intercepts, 2 solutions. Also notice both of the ones I've drawn open down because graphs that open down would have a maximum value. And let's create one more just with a different x-intercept. We'll use, a different maximum. We'll use 6. And if I put this right here, so we are 4 away. I have to make sure I'm going 4 away in the other direction. We're 5 away. Which puts me way back here at negative 7. Kind of starts going off the graph. So we would do the same thing over here. Notice this time it says it has a minimum value, meaning our graph needs to open up. And a y-intercept at negative 5. So as long as you draw me a parabola in which the y-intercept is at negative 5, it has no solution, so it doesn't cross that axis, we're good. Your graph could look something like this. It could be really narrow. Your graph could be really wide, but it's got to have a minimum, and it needs to cross through that y-intercept of 5. No solutions. Whatever you chose to draw there. Here we would start solving. Now remember, I mentioned earlier you must have it in standard form in order to graph it. And when we are looking at an equation in standard form, we should be able to graph it as long as it is equal to 0. Because we are looking for the x-intercepts, so our y value equals 0. Think about it. Every ordered pair that is an x-intercept is an x-intercept, comma, 0. So, x value, comma, 0. So if I were to sketch this graph, and y'all definitely should use Desmos or your graphing calculators, I would see something like this pop up. Well, we can see that there is one solution there as the graph sits directly on the axis, and the solution is 5, 0. We would do the same thing with the graph on the right, and I'm going to let y'all take time to do that. If I'm ever moving too fast, you can always pause it, finish working, and then come back. Now, we need it to equal 0. So we're going to have to use inverse operations to get it equal to, to get it equal to 0, which would give us 2x squared minus 12x plus 18 equals 0. Now that it equals 0, we can either type this into our calculator, type that into Desmos, or type y equals that into Desmos. You could use f of x instead of y if you wanted to. If you're using your graphing calculator, you should notice that it already has f of x, so you're just going to type in the other side, or the right side in that case, of the function. From there, you would be able to find your zeros. If you're using your graphing calculator, your yellow calculator, to find the x-intercepts, you are going to go to, actually, I'll talk it through you on this one. So, to use the yellow calculator, you're going to hit Home, New Document, Don't Save, Home, New Document, Don't Save. From there, you are going to be sure that you select Add Graph, because we want to graph this. When you add graph, you would be able to type in the 2x squared plus 8x plus 1. Once you've typed it in, you're going to hit Menu, then select Analyze, Zeros. A dotted line is going to pop up on your screen. You want to click to one side of your parabola, the 0 that you're trying to highlight. So let's say that 0 is right here. We're going to click right here so that it's highlighted on one side. You're then going to drag to the side until you've highlighted it. So you've shaded it over, and the dotted line should then appear on the other side. Click again, and that should tell you the value. So that would give you your two values. Now, on this question, you should notice you do not get whole numbers. So that would eliminate A and B. To decide between C and D, you're going to enter this in your calculator and see which answer is equivalent to what you got as your answer. All right, that's it, guys.